Looking at the current source, the circuit is operating at omega equal to 2 rad per second. Now converting this into the frequency domain, we have the circuit. We have 10 angle 0, we have 2, we have negative J 2.5, we have J times 4, and then 4, and we have 3 Vx. This is our Vx right here. And we have node voltages. We have V1, then V2. Now for this problem, we need to solve for the we need to get the expressions for the node voltages V1 and V2 in time domain. So applying KCL at node V1, we have negative 10 angle 0 plus V1 over 2 plus V1 minus V2 over negative J 2.5 equal to 0. Now rearranging and combining like terms, we have 0.5 plus J 0.4 times V1 minus J 0.4 V2 equal to 10 angle 0. We have our equation number 1. For equation number 2, apply KCL at node V2. So for node V2, we have V2 minus V1 over negative J 2.5 plus V2 over J4 plus V2 minus 3Vx over 4 equal to 0. Now looking at the circuit, our Vx is just equivalent to V1. Now same with equation number 1, combining like terms, we have negative 0.25 minus J 0.4 Vx plus 0.25 plus J 0.15 V2 equal to 0. So we have our equation number 2. So 2 equations, 2 unknowns. You can now solve for the values V1 and V2. So you can use a substitution or the matrix form. So in matrix form, this equation is V1 is just equal to delta 1 over delta, and our V2 equal to delta 2 over delta. So our delta is just the determinant of this matrix. So this is equivalent to 9 over 40 minus J 1 over 8. So for delta 1, we have this is equivalent to 2.5 plus J 1.5. Now for delta 2, we have this is 7.5 plus J 4. Now solving for the values of V1 and V2, So V1 is just equivalent to 5.66 plus J 9.811, or which is equivalent in polar form 11.327 angle of 60.02 degrees volts. And for V2 we have 17.925 plus J 27.736. In polar form, this is equivalent to 33.024 angle 57.127. So lastly, converting into time domain, V1 is just equivalent to 11.327 cosine of 2t plus 60.02. Then for V2, we have 53.024 cosine of 2t plus 57.127 degrees. So we have our final answer. Now for our next example, we'll use mesh analysis. So let's label our mesh currents. Our negative IO. This is negative 10 angle 0. This is applying KVL at mesh negative IO. We have negative 8 IO plus J2 IO plus J4 quantity negative IO minus I equal to 0. So rearranging this equation, we have our equation number 1. Applying KVL at mesh I, we have G4 and quantity I plus IO plus 6 quantity I plus 10 angle 0 plus 50 angle 30 degrees equal to 0. Now rearranging the equation, we have our equation number 2. So we have two equations, two unknowns. Can now solve for IO. So IO is equivalent to uh, delta O over delta. So same with the last example, we'll use the matrix or determinant. So our delta is just equivalent to, we have negative 56 minus J44. Now for our delta O, so delta O is equivalent to 425.132 angle of negative 76.395 degrees. So finally, our IO is equivalent to 5.969 angle of 65.45 degrees fierce. So next example, use superposition to find the expression VO in time domain. So first, let's label the sources as V1. This is I1. So V1 acting alone, we have omega equal to 5 rad per second. Now converting the circuit to the frequency domain, we can simplify the circuit to a single loop. We have so ZEQ is just equivalent to negative J parallel with J5, which is equal to negative J 1.25. Now by VDT, or VO, equivalent to ZEQ over ZEQ plus 8 times 75 angle negative 90, where VO with V1 acting alone is equivalent to 11.578 angle negative 171.12, or in time domain this is equivalent to next when I1 acting alone, or omega, is equivalent to 10 rad per second. So our circuit is, so again we can uh, simplify this circuit into a single loop. Our ZEQ is equal to, so we have J10 parallel with negative J 0.5 parallel with 8 is equal to 0.525 angle of negative 86.34. So by Ohm's law, our VO equivalent to 6 times ZEQ equal to 3.151 angle of negative 86.24, or in time domain, so our VO, so our combined response due to the two sources equivalent to these two responses. So we have VO of t equal to 11.578 cosine of 5t minus 171.12 plus 3.151 cosine of 10t minus 86.34 volts. We have our final answer.